Hello students, myself Dr. Sofia Gupta. So in this video we'll study about molecular orbital theory. It is also known as MO theory. Before starting the molecular orbital theory, we should be aware of some basic concepts. Firstly, what is orbital? So basically orbital, it tells about the probability of finding the electron in a space. Okay, for example, we are having s orbital, p orbital, d orbital, f orbital, and so on. We know the shape of s orbital is spherical, so the probability of finding the electron is over here. The shape of p orbital is dumbbell shape, so the probability of finding the electron is over here. Clear? Then is atomic orbital. Atomic orbital is basically the space around the nucleus. This is your nucleus, the space around the nucleus in an atom where the probability of finding the electron is maximum. Then is molecular orbital. By combining the atomic orbital, we will get the molecular orbital. For example, this is H atom. If I combine two H atom, we'll get H molecule. Similarly, by combining two atomic orbital, we'll get two molecular orbital. How much atomic orbital you will combine? If you are combining n number of atomic orbitals, then you will get n number of molecular orbitals. Okay, then fourth concept is nodes. What are nodes? These are the point where the probability of finding the electron is 0. For example, in this p orbital, these points are node. Here there is no probability of finding the electron, means the electron is only present in this space. Now moving on to the molecular orbital theory. So according to this theory, when two atomic orbitals combine together, they will give two molecular orbital. One will be of lower in energy and one will be of higher in energy. The molecular orbital which is of lower energy is known as bonding molecular orbital, and which is of higher energy is known as anti-bonding molecular orbital. See, when the two atomic orbitals they come together, they may either overlap constructively or in a destructive manner. Okay, so constructive manner is like, see, one atomic orbital, it is represented by a wave function, and other I am also representing it as a wave function. Okay, so when they overlap constructively, this means that this is a wave function of first, this both will overlap, that is chest of one will overlap with the chest of the other. Destructive overlapping means the destructive overlapping means the chest of one is on the trough of the other. So when the overlapping is constructive, it gives rise to bonding molecular orbital. Okay, when the overlapping is destructive, it gives rise to anti-bonding molecular orbital. Bonding are of lower energy, anti-bonding are of higher energy. Okay, see, each atom is having different atomic orbitals, so the atomic orbital will be combined to give bonding and anti-bonding molecular orbital. Now same is represented in this diagram. See, 1s orbital and 1s orbital, these are the atomic orbital Now we are having two atomic orbital. Now two atomic orbital, they will overlap, they will give two molecular orbital. See, this is first molecular orbital, this is first one, and this is second molecular orbital. Okay, so this one is bonding molecular orbital, which is lower in energy and it is more stable, and other one is anti-bonding molecular orbital, which is high energy and it is less stable. High energy and it is less stable. Clear? Now we will discuss about the rules for writing the, this is actually electronic configuration for molecules. Now we know atomic configuration, we know, for example, of nitrogen, we know its atomic number is 7. So atomic configuration is 1s2, 2s2, 2p3. Now if you are getting N2, now this is a nitrogen molecule, so how we will write its electronic configuration, that for that we'll study some rules. Okay, now the first rule is of Bohr's principle. Okay, according to this principle, basically this principle tells that always the electron will occupy lower energy molecular orbitals. Okay, when we'll start filling the electrons, the electron will first occupy the low energy molecular orbital, then it will go to the next. Then is Pauli's exclusion principle. In this, maximum of 2 electrons are there in a single molecular orbital. मतलब if you are having a molecular orbital, either it can have 1 electron or 2 electron, it cannot have more than 2 electrons. Then is Hund's rule. According to this rule, if your orbitals are degenerate, then each orbital is singly filled before getting paired up. Okay, now what are degenerate orbitals? See, degenerate orbitals are those orbitals which are having same energy. Okay, like we know that P is having 3 subshell, Px, Py and Pz. We represent it like this. Okay, these are 3 degenerate orbitals. Now if supposedly I am having 5 electrons, how I will fill that? We cannot fill in this sense that 1, 2, 3, 4, 5. No, that is wrong. The correct order is, firstly you have to singly fill 3, then you have to pair up 5. Total in a single orbital, maximum 2 electrons are possible. Now we'll come to how to write the electronic configuration of a molecule. If the molecule contains more than 16 or 16 electrons, then a particular rule will be follow. If it is containing less than 16 electron, then other rule is follow. Now we'll discuss the case 1, when a molecule is having less than 16 electrons. Okay, then we'll follow this order. This is the increasing order of the energies. Increasing order of energies of the orbit, of the molecular orbital. Okay, if it is containing less than 16 electron, then you have to fill in this electronic configuration. Case 2 is if it is having greater than or equal to 16 electrons, then you have to fill in this order. For example, let's say uh, C2. Okay, so there are two carbons, one carbon is having 6 electrons, other is 6, so 12 electrons. So we will fill the 12 electrons in this configuration. Similarly, N2, N plus N, 7 plus 7, 14 electrons, so we'll fill in this. For example, if I say for N2, the electronic configuration will be, total is 14, 2, 1 here, 2, 4, 2, 6, 2, 8, then you have to fill like that, 1 here, 1 here, then pair up. Okay, so it will be 2, 2, total is 2, 4, 6, 8, 10, 12, and then is 14, right? Now if the total number of molecules is electrons is either 16 or greater than 16, then you have to write this. For example, we are having oxygen, total 8 plus 8 is 16, so you have to fill 16 electron in this electronic configuration. Then you can consider F2, F plus F, this is F is 9 plus 9, 18, so 18 electron you have to fill in this configuration. Let's say 18, so 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. Because these are degenerate orbitals, equal to sign represents the degeneracy this. So firstly you have to single fill, then you have to pair up. Similarly, these are degenerate orbitals. I have told you for the degenerate orbitals, firstly you have to single fill, then you have to pair up. I hope this is clear. Now the main difference is basically between the two electronic configuration is this, sigma 2pz. In less than 16 electron it is after pi 2px, pi 2py. In greater than equal to 16 electron it comes here, so this is before 2px and 2py. So this you have to learn how to fill the electronic configuration. Just you have to remember, you have to calculate the number of electrons. If it is less than 16 electron, case 1 will be followed. If it is greater than equal to 16 electron, then case 2 will be formed. Okay students, so in the next part 2 we'll discuss some examples, how to draw the molecular orbitals, and also we'll study about bond order, magnetic properties of the molecules. Thank you, and if you are having any doubt, kindly pin down in the comment section.